Good afternoon, everybody. My name is Arnaud Macia. I am a civil engineer and I am working currently for Hydrogenica, which is a company located near Barcelona. And today I am going to speak a little about new fuels or fuels in general, LNG, its sources, and supply and bunkering of LNG. Well, the contents of the class will be distributed in three big blocks. The first is fuels. We will see traditional new fuels and we will compare them. Then we will see something about natural gas, the origin, its properties, what is LNG, and its supply chain. And finally, we will see something about bunkering, the types of bunkering and what is bunkering. Well, the first block is fuels. First of all, what is a fuel? Okay, a fuel is a material that has the capacity to store an amount of energy, and this amount of energy can be used for work or as a heat energy. It is important because the fuel is the origin of the energy that it stores. It is the reason why electrical energy is not a fuel. Because electricity is not the source of the energy, but is only the way to transport it. We can find fuel in the United States. They can be solid, liquid, or gaseous. Traditional solid fuels are coal and wood. Liquid are oil derivatives. And the most common gaseous fuels are natural gas or hydrogen. Well, first of all, a little history about fuels. People began to use fuels basically for heating ourselves and for cooking our food. And the first fuel ever used was wood to make fire. But with the Industrial Revolution and the apparition of the steam engine, coal became to be the main fuel used for transport and for industrial applications. The steam engine make the with the steam engine appeared the steam locomotive and the steam ships, and this was the way that coal began to be used as a transport fuel. And then, mainly due to its flexibility and the technical development that began to exist, oil-derived fuels were adopted instead of coal for some industrial processes and mainly for transport. So basically, the way that fuels have followed since the origin to nowadays is that are shown in these pictures. First, wood for cooking and heating ourselves, then coal in transport, in steam locomotives and steam ships, and finally oil-derived fuels. Well, first of all, traditional fuels. The main traditional fuels that we know nowadays are diesel, gasoline, and fuel oil. In this table, we can see the energy content, and we can see that there is not a big difference between the most energy powerful and the lowest. Nowadays, these three traditional fuels are the three oil derivatives, and they come from distilling oil. And its offer, of course, depends on the rate of extraction of oil. In 2014, global consumption of oil was almost 89 million barrels per day, with a proved reserve of 1,700 million barrels. It makes a global rate of reserve production of 53 years almost, and that means that if we keep consuming the oil at the rate that we have been doing during the last year with the proved reserves that we know nowadays, we have still oil for 53 more years. The main producers are Middle East countries, USA and Russia, while the main reserves are located in Venezuela, Middle East and Canada. Venezuela is the biggest reserve of oil in the world. And on the other hand, we have new fuel. What's called a new fuel? New fuels are actually not anything new. New fuels are known since decades. But new fuels are these fuels that nowadays are beginning to be used for transport, mainly for transport. And its development, the main purpose of its development is to find cleaner and cheaper fuels, alternatives to the traditional fuels that are diesel, gasoline, and fuel oil. Well, the types that new fuels nowadays we know. The first one is ethanol, that is produced from plant material. Usually it is used mixed with gasoline with a mixed ratio that varies from 10% to 83%. It reduces dramatically the mixed energy content, and not all gasoline engines tolerate high ethanol rates. So it has some disadvantages. The second one is biodiesel. It is produced from vegetable oils and animal fats. It can be used by itself or mixed with diesel, and not all diesel tolerate, as it happened with ethanol, high biodiesel rates. The third is natural gas. Natural gas, as I said before, it is not actually new, but it is beginning to be used nowadays for transport. It comes from wells. One of the main advantages is that it reduces dramatically the air pollution rates. Diesel or gasoline engines can be adapted to natural gas, but they can also keep using their original fuel, and prices are lower than diesel and gasoline. Another important advantage. The last one is LPG. It is also an oil derivative, but it's not been used for years for transport, so it is considered also a new fuel. It reduces some harmful emissions, not as natural gas did, but it also reduces some harmful emissions, and price is lower than diesel. Its main advantage. In this table, we can see which is the energy content of every new fuel. We can see that ethanol has a lower energy content than the other three, while the other three are more or less, well, it's not the same, but the difference is about 20% between the most and the least. Biofuel production, that it includes bioethanol and biodiesel, in 2014 was almost 71 million tons of oil equivalent, while oil production in the same year was 4,220 million tons, which makes only 1.68% of bio oil production compared with oil production. It's not really representative nowadays. While gas production in the same year was 3,127 million tons, and its ratio production reserve is 187 years. That is so important because it means that keeping our consumption ratio, we have still 187 years of gas, that compared with 52.7, I think it was, oil, it's higher, it's so higher. Well, comparing new fuels versus traditionals, of course, there are advantages or disadvantages of every type. On one hand, we have traditional fuels, whose technology is already developed. It is an important advantage. There are lots of engines, lots of cars, lots of models of trucks that some brands offer nowadays to be bought at really competitive prices. Another advantage is its versatility and its supply. There are lots of supply points where we can fuel our car, our diesel or our gasoline car. While its advantages is that the pollution levels are higher than new fuels generally, that the cost is beginning to increase and is usually higher than new fuels, and that reserves are low and they are lower every year. On the other hand, we have new fuels, which are generally cleaner. Its pollution levels are lower. Its prices generally are also lower. The reserves that we still have of these fuels are larger, are bigger. Some of them are renewable, actually. But on the other hand, we have less supply facilities for these kind of fuels. The investment that we have to do initially is higher, because usually new fuel engines are more expensive than traditional ones, and some technologies are still in development. Let's study a case where we will compare a traditional diesel fueled truck with an LNG, a natural gas fuel truck by Iveco, the Iveco Australis. The assumptions for the case of study will be the following. The diesel cost is €1.90 per liter, but diesel cost, the diesel cost of nowadays. Then LNG cost will be 78 cents per kilo.
Per la lunghezza.
The first investment, the initial investment, will be €21,000, which is the real investment. And let's assume that this truck will have 120,000 kilometers per year. Well, with these assumptions, we see that the savings of every year are almost 16,000 euros, and the period of amortization is less than 50 years. This is so important, because it means that it is really a good investment to use LNG trucks and LNG trucks, and that's why nowadays there are lots of companies that are planning to change its fuel from diesel to LNG. Well, now let's talk a little about natural gas in general. First of all, what is natural gas? Okay, natural gas is not actually a single gas. It is a mix of different gases whose principal component is methane. Its composition depends basically on the country of origin of the natural gas. Here in this table we have three different examples. The first is from Algeria, the second is from Libya, and the third is from Qatar. These data are taken from Sedigas, and we can see how the composition of the natural gas varies from one well to another well. But basically, we can see that methane is at least 87% of the 83% of the composition, while ethane, propane, butane, and other heavy hydrocarbons are less than 10%, 12% more or less. There is also a small quantity of nitrogen, and its energy content in megajoules per kilo is, well, it's not the same, but it is so similar depending on the well it comes from. Well, first of all, natural gas is extracted from wells, and originally it is found in gaseous state. Then transport of the gas can be performed by pipeline in gaseous state or by ship and trucks, but it must be in liquid state. At normal conditions, which is considered 0 degrees and 1 atmosphere of pressure. Natural gas is found in gaseous state. This is more or less the conditions in which it is found in the nature. But it can be liquefied by chilling it down to cryogenic temperatures, which means more or less going to minus 160 degrees at 1 atmosphere. This pressure of 1 atmosphere, liquefied natural gas specific volume is approximately 600 times smaller than gaseous natural gas. And this is so important. And this is the main reason why it is so interesting to liquefy natural gas. Originally, natural gas is odorless and colorless, but for safety reasons, basically for detecting leaks, natural gas is odorized before consumption. And at normal conditions, natural gas is lighter than air. It is not toxic, but being not toxic, it can cause asphyxia by air replacement. It takes the place that air took. And thermodynamic properties are similar to methane. So when we have to make calculations about the processes of natural gas, we usually take the methane's properties. And then we have LNG, which is nothing more than liquefied natural gas. So basically the material is the same, but it's liquefied, so it changes its state. And why we liquefy natural gas? Basically because the density, as I said before, is approximately 600 times higher than natural gas. So it is the only economical way to transport it large distances in ships or trucks. LNG also permits to store large amounts of energy in limited space. In 2014, 1/3 of the international energy trading was made by LNG. LNG properties as a fuel are the same as natural gas, but it is a liquid, so it is an odorless and transparent liquid. Its temperature generally varies from minus 160 to minus 100 at normal operating pressures. Its approximate density is 450 kilos per cubic meter. It also depends on the temperature and its composition. And LNG vaporizes at atmospheric conditions. When we find where we find an LNG leak, that it happens something that is very, very particular, and it is that the atmospheric humidity solidifies because of the low temperature of the leak, creating a white cloud around the origin of the leak, as we can see in this picture here. LNG combustion as natural gas is cleaner than oil derivatives. It generates a minimum amount of sulfur dioxide and nitrous oxides, and carbon dioxide emissions are also smaller than oil-derived fuels, more or less 20 and 10% lower. Well, the LNG supply chain begins exploring and drilling. The second step is the gas production. The third is liquefaction. The fourth is shipping. Then comes storage and regasification at the importer countries. Finally, pipeline delivery and finally consumption. As we said before, natural gas is extracted from wells. These wells can contain only gas, or they can contain also oil. When the well from which the natural gas comes from, it contains also oil, we say that it is an associated natural gas, and this well is called an associated well. And when the well contains only gas, we call this gas an unassociated natural gas. Depending basically on logistic and technical conditions, basically location of the well, the complete amount of gas that is located in this well, the availability of treatment facilities and other conditions, natural gas from oil and gas from associated wells can be or not economically used. Where it cannot be economically used, sometimes it's burned off in flares in the same field, and sometimes it is reinjected, waiting for the conditions to change, basically waiting for the price to become higher. Natural gas extracted sometimes contains significant quantities of heavy hydrocarbons, and they are almost always removed from the natural gas because of two reasons, basically. The first is economical, and it's because the price of heavy hydrocarbons is higher than natural gas, so it is money. And the second one is technical reasons, that it's because natural gas later process does not tolerate high rates of heavy hydrocarbons, so it must be removed if we want to liquefy. Well, when natural gas is transported by pipelines, it must be compressed and sent to destination to its consumption points almost directly. But when natural gas is destined to the LNG market, it's liquefied in a liquefaction plant. This plant is the place where the gas is liquefied and liquefied, sorry. And its basic parts are the pretreatment, liquefaction system, the storage, a loading facility, generally a power generation plant, and there can be also other systems in the same plant as cooling water systems, nitrogen production, or water treatment, or other auxiliary systems. The first step, which is pretreatment, has the objective to remove different things. The first is solid particles, and they are removed because they can cause damage to the plant equipment and to the consumption devices. The second one is mercury, and it is because it causes damage to aluminum-made equipment. Then heavy hydrocarbons, if they have not been previously removed, as we said before. Then carbon dioxide, and it is because it solidifies at -57 degrees, and that would block the LNG pipes. And the same happens with water that solidifies at 0 degrees.
Se aumento di diametro diminuiscono i gas comunitari, spendendo questo.
Risparmiando questa cosa. Però in questo caso è quindi devi fare niente via.
Mine systems are usually in place when the quality of carbon dioxide is high. In this process, it is produced to the pipes an amount of waste gas with a high proportion of carbon dioxide, and this waste gas it is usually used in various parts of the plant for fueling boilers, cooling engines that tolerate low quality natural gas, and this is a way to make the whole process more efficient. Then, once the gas has been treated and it's been cleaned out of these substances, it is sent to the liquefaction part. The way to liquefy natural gas basically is lowering its temperature to cryogenic temperature. There exist different processes, but they all use auxiliary fluids called refrigerants, which can be only one refrigerant fluid or more than one. And depending on the plant scale, on the amount of gas that it is treated in the plant, the best liquefaction cycle is. Generally, small-scale liquefaction plants, more or less up to 0.1 million tons per year, usually use nitrogen expansion cycle. The way it works is so simple, but they can be single-stage nitrogen cycle or three-stage nitrogen cycle, as we see in these pictures. Basically, nitrogen is compressed, then it is cooled and finally expanded. So we dramatically drop its temperature. Then heat is exchanged between natural gas and the cold hydrogen inside the cold box. Natural gas to liquefy. And as I said before, this compression and expansion of nitrogen can be in single stage or in consecutive stage. The main advantages that these nitrogen cycles offers to owners of plants is that there is only one refrigerant that makes it simple, that this refrigerant fluid is inert and cheap. Nitrogen can also be easy self-distilled where it is not commercially available. And it is also used in other parts of the plant for other purposes, basically for inertization. This picture shows a small liquefaction plant located in Ecuador, in Machala, and this part here, I don't know whether you can see the, yes, they can see. Okay, you can see the course. So this part is a plant whose object is just making nitrogen to feed the liquefaction. On the other hand, large liquefaction plants, 1 million tons per year and bigger, usually use cascade liquefaction cycle, which implies using more than one refrigerant and more than one stage. This picture shows the flow diagram of a cascade liquefaction cycle. They are more complex, as you can see, but they offer higher efficiency, so it means saving energy, but also implies higher investment and higher operating costs. Once it's been liquefied, natural gas must be stored before transporting to the consumption points, and this step, this storage, must be performed conserving the LNG under its equilibrium point. So heating must be avoided to prevent the boil-off. The LNG heating is prevented by means of insulation. Basically, tanks and pipes are insulated from medium, or it can be either covering them with polyurethane foam or creating a vacuum chamber between them and the medium. On one hand, polyurethane offer an easy performance, versatility, low cost, but they offer to us less thermal efficiency, while vacuum is technically more complex than polyurethane insulation. There is few experience in general performing this kind of insulation. Its cost is higher, but its thermal efficiency is so high. Storage is basically performed in cryogenic tanks. They can be pressure tanks or they can be atmospheric tanks. The first kind, pressure tanks, usually cover the range up to 200 cubic meters. They are almost always vacuum insulated. They are manufactured at shop, which means quick assembling on site. Its pressures varies from 5 to 20 bars, basically, which is so useful for some users. It implies no need of pumps in some applications. They are used only in small-scale liquefaction plants. On the other hand, we have atmospheric tanks, which cover the range from 500 cubic meters. They are insulated basically with perlite and foam glass. They are constructed on site, which implies a longer term of construction. Its pressures are usually below 0.5 bars, and usually they are used in medium or large scale liquefaction plants and storage and regasification plants. Well, here we can see two pictures with pressure tanks. The first one is a vertical pressure tank, and the second one is an horizontal pressure tank. This is mainly the only difference between both because the system is exactly the same. They have a double tank. The inner tank is made of stainless steel, while the outside tank it is usually made of carbon steel. And the chamber between both tanks is insulated with perlite and vacuum. Manufacturers usually assure that its boil-off ratio is less than 0.05%. And on the other hand, atmospheric tanks, they also have a double tank. The inner tank is always made of stainless steel, while the outside tank can be made of carbon steel or reinforced concrete. Generally, the bigger are made of reinforced concrete, while medium tanks are made of carbon. The chamber between both tanks is thicker than in pressure tanks, but it is not vacuum insulated. It is insulated with perlite only, and bottom and deck it is usually insulated with foam. When LNG must be transported long distances, it is usually performed by carrier ships, while short distances are usually covered by LNG road trucks. So large-scale liquefaction plants are usually located at coastal zones, so they can deliver the LNG directly to ships by means of a ship loading facility. In this picture, we can see a ship loading facility. While small-scale liquefaction plants usually provide LNG to local consumers, and this LNG is transported by road truck. So they have truck loading facilities where LNG is transferred from tanks to trucks. Here, this loading facility is located in Chile, in I don't remember the location exactly now. In Quinteros, yes, it is in Quinteros. Liquefaction plants are usually located in isolated areas where power supply is not available. So they are designed to work independently, producing its own electricity in a power generation plant. These power generation plants usually consist in gas turbines or gas engines fed with residual natural gas, as we said before, from the treatment stage, and this fact makes the whole process more efficient. This picture, for example, shows the power generation plant of a liquefaction plant located in Bolivia. property of yacimientos petrolíferos fiscales de Bolivia. Long distance transport of LNG is performed basically by means of LNG carrier vessels, whose capacity usually is up to 260,000 cubic meters. There exist different designs for these carrier vessels, but they all can be classified into big groups. The first, is the self-supporting tank system that consists in a ship containing a series of spherical prismatic tanks that are insulated and supported by the structure of the ship, but they are independent of the vessel hull. While the other type, which are membrane types, the tank adapts exactly to the shape of the vessel. And it is the hull of the vessel who supports the load of the tank and of the LNG. In these two pictures, we can see in the first one a self-supporting type LNG vessel, and in the second one a membrane type. Short distances, as we said before, usually are covered by LNG road tracks. Capacity is up to 64 cubic meters. Road tracks as pressure tanks can be vacuum insulated or polyurethane insulated. On one hand, polyurethane offers less cost, but its boil-off ratio is higher, and this type is not allowed in the European Union for building new units. While vacuum offers lower boil-off ratios, but its cost is higher, but they offer us a higher safety level. In this picture, we can see some vacuum insulated road LNG trucks. The step once the LNG has been transported is regasification. So LNG vessels are received at storage or regasification plants, which are located basically in importer countries. Regasification plants receive, store, and regasificate LNG, and natural gas, once it's gas state again, is transported by pipeline to its final consumer. Part of this LNG received at the regasification plant is sold at liquid state and transported by LNG road trucks again. In an LNG regasification plant, its main parts are the reception terminal of the LNG, the storage devices, which are atmospheric tanks basically, the regasification system, a boil-off recovery system, and if part of the LNG is sold or it is transferred to trucks, they have a truck load facility. Energy needed for regasification of the LNG is usually taken from sea water by means of a heat exchanger system. And in this picture, we can see a regasification plant whose most characteristic feature is its big atmospheric tank. And here we can see the European LNG system, storage and regasification system. In green color, we see the existing facilities, while in red we can see those that are under construction or commissioning right now, and in yellow we see those that are still planning or under study. this was for LNG, which was transported by vessel, but the LNG that is transported in road trucks is employed basically in satellite regasification plants or other small-scale consumption facilities. An LNG satellite regasification plant is basically a small facility whose purpose is regasificating LNG to feed small-scale consumption points. Generally, satellite plants feed industries or insulated population centers not covered by pipeline. Its main parts are so similar to regasification big plants. First, the LNG storage, then the regasification system, but they have also an authorizing system and regulation and metering station. In this picture, we can see a regasification plant, a satellite regasification plant, with its main parts. There are 6 or 7 vertical pressure tanks where LNG is stored. Then the regasification system, which we cannot see actually, the regulation and metering station, and the authorizing. The storage of the LNG at satellite plants is performed basically by pressure vertical or horizontal vacuum insulated tanks. Its number and its capacity of these tanks depend basically on several factors. The first is the average consumption. The second is the presence or not of consumption peaks, and the supply warranty that we need. And the type of tanks, vertical or horizontal, depends basically on space possibilities, because horizontal tanks need more space. The capacity of the tanks, because standard vertical tanks are usually manufactured up to 100 cubic meters, while horizontal tanks are up to 200 cubic meters. It also depends on the maximum height allowed by the legislation, and it depends also on the seismic condition, because horizontal tanks can accomplish higher seismicity requirements than vertical tanks. In these two pictures, we can see two different satellite regasification plants. The first, in the first, there are vertical pressure tanks, while in the second one there are horizontal tanks. As we said before, to regasificate LNG, we need to heat the LNG, we need to heat LNG beyond its boiling temperature, and natural gas to be employed successfully must be supplied at a minimum temperature of 0 degrees. So the regasification system needs to transfer enough energy to LNG to regasify up to its consumption temperature the natural gas, which is more or less 0.26 kilowatts per hour per kilo of gas. The heating of LNG is always performed with vaporizers. There are two main kinds. The first kind is ambient air vaporizers, while the second one is heat vaporizers. And both kinds are sometimes combined in the same plant. The first kind, ambient air vaporizer, it is a simple device consisting basically in a finite tube which enlarges the area of heat transmission. And LNG interchanges energy with ambient air in this device. They do not need any heat source but ambient air. They are usually installed in groups which work in turns. While one group is vaporizing the LNG, the other one is regenerating itself. They are so easy to install and operate. but they need dry ambient air because humidity makes them to saturate quickly. And sometimes they are installed combined with reheaters. First, LNG regasificates in ambient vaporizers, and then reheaters. They can be electrical heaters or hot water reheaters, make it reach its consumption minimum temperature. The second kind, the heat vaporizers. In them, LNG interchanges its energy with an auxiliary fluid, which is basically heated by an energy source. The most common type consists in a tube heat exchanger where LNG is heated by glycol water. They need a heat source, which is usually gas boilers or sometimes residual energy of an industrial process. One of its main advantages is that it can work continuously and do not depend on any special ambient condition, but they need a more complex control system. Its price is more or less the same. Once the gas has been already regasificated, it must be odorized. Odorizing is performed because of safety reasons, basically, and it's because natural gas is odorless and colorless, so it is difficult to detect leaks. The way to odorize it is adding to it some THC. THC is a gas that has an intense odor, which makes the natural gas leaks easy to identify without any special device. And before sent to consumption, natural gas must be pressure regulated. Pressure must be regulated, and flow must be measured in a regulation and metering station. Here in the picture, we can see a skid, which includes the regulation and metering station and the odorization system. Natural gas can also be consumed as a fuel for explosion engines, as we saw at the beginning. And the way to supply it to the explosion engines its fuel is a natural gas fuel station, which basically consists in a vertical or some vertical horizontal pressure tanks, pumps, vaporizers, compressed natural gas bottles, LNG dispensers, and compressed natural gas dispensers. And now our third block will be bunkering. Well, first of all, what is bunkering? Bunkering is the common name that receives all the operations whose object is refueling a vessel. Traditionally, marine fuels are oil-derived fuels, but with new legislation and creation of ECAs, which are emission control areas, the ship owners have been forced to find cleaner fuels to lower the emission the emissions of its ship. LNG basically offers to vessel operator an alternative to traditional fuels, with which accomplish the new regulatory requirements, basically low emission rates, and it is also economically competitive. Another advantage is that LNG ship engine technology is already developed, because LNG cargo vessels have been fueled for years with the boil off recovered from their tank. There are different ways to perform the LNG bunkering. The first is truck to ship, and then we will see onshore to ship and ship to ship ways to perform it. Truck to ship is the way to fuel LNG vessels, where the ship is directly fueled from an LNG road truck connected by cryogenic hoses. The transfer is performed by means of the LNG pump of the road truck, or by means of pressure difference between the truck and the ship tanks. And the transfer velocity is basically around 10 tons per hour. Its main pros are that it is a flexible system. It does not require a high investment. The operational costs are also low, and they do not need any special. While its capacity is limited, as we said, its transfer velocity is low, and sometimes its performance is difficult because it requires a big deal of space onshore on the docks. Here in this pic we can see how
E poi cambi solo il numero di... Ne trovi tutti gli altri puntini su quella riga, invece poi cambi anche ne, ci metti 2.
It is basically truck to ship bunkering system.
0,38. Hai detto? Ok, scusa.
And let's see now a practical case of a bunker that was fueled by a truck-to-ship bunkering system. The ship was a ferry called F.A. Gautier, that is property of the Société des Traversiers du Québec. It was the first LNG fueled ship constructed in Italy in 2014. Its main features are 133.2 meters long, 22.4 meters of beam. Its capacity is 800 people and 180 vehicles. Its main engines were sealant. The total power of the engine system is 20,880 kilowatts. Its velocity is 20 knots, and it has a 250 cubic meters capacity of LNG tank. It was fueled employing the truck-to-ship system during the test period in Italy. The LNG was brought from the regasification plant that Enagás has at Barcelona, which implied 1,600 kilometers from the terminal of Enagás to the shipyard. 7 road trucks were necessary to supply this LNG during the test. The transfer was made by means of a 30 meters hose, and LNG was transferred by means of the pressure difference between the truck and the LNG tank. Well, the second way to perform LNG bunkering is onshore to ship. When it is performed, the ship is fueled directly from an onshore facility set in a fixed point. It is sometimes so useful because bunkering can be performed regularly from a fixed point, and it is also useful when storage plants are located far from the bunkering points, because it provides a secondary storage facility. And LNG transfer velocity is more or less up to 100 tons per hour, which is, if I am not mistaken, 5 times the velocity of truck to ship. Its main features is that the LNG is stored in pressure atmospheric tanks. The facility is there are in the facility cryogenic pumps, and the transfer of the LNG from these tanks to the ship is performed by means of flexible hoses or loading arms. They are usually designed in modules. The first module is the storage module, consisting in different tanks. Basically, they can be vertical or horizontal. They can also be pressure or atmospheric, so they tolerate all kinds of tanks, whose usual size are from 60 to 1,000 cubic meter, but they can be larger if it is needed. And the loading of the facility tanks can be performed from trucks, either employing the truck pumps or static pumps located at the bunkering facility. Basically, there are two kinds of cryogenic pumps which are employed in this kind of facilities. The first is cryogenic pumps, centrifugal cryogenic pumps, and the second one are centrifugal submerged pumps, whose output can vary from 40 to 200 cubic meters per hour, more or less. These pumps usually are provided in skids, which not includes only the pump, but also include the valves associated with the pump, its instrumentation, its electrical installation. This is what we call plug and play devices, which means that you only set the skid there, and all you have to do is to connect it with the correct pipes and the correct wire. And finally, the loading module, which can consist in manual cryogenic hoses or in loading arms, which can be mechanical or automatic. These three pictures show the three ways to get the three kinds of loading devices. The first one are flexible cryogenic hoses. The second one is an automatic loading arm, and the third one is a mechanical manual loading arm. And to see a practical case also, we will see something about the Bucabus project. It was performed in Argentina. The ferry is the ferry Francisco, which is owned by Bucabus. It covers the route between Buenos Aires to Montevideo twice a day. And the project scope, and this is maybe the most interesting feature of this project, was that the project covered not only the bunkering facilities, but also the liquefaction plant that was constructed to provide the LNG to the facility. It is property of Bucabus. So the from the Argentinian net, it is liquefied in a liquefaction plant. Then it is stored at cryogenic tanks by means of, transferred by means of submerged pumps. Then from there, road tracks are loaded, and these road tracks transport the LNG from the liquefaction plant to the docks where bunkering is performed by means of a flexible hose and a mechanical. The ferry has capacity for 1,000 people and 150 vehicles. As I said, it covers the route between Buenos Aires and Montevideo twice a day. Its consumption is 80 cubic meters per trip, which makes 160 cubic meters per day, which is exactly the capacity of the liquefaction plant. This LNG is transported, sorry, to the dock by means of road trucks. 4 daily trips are required. And the project was the 2014 winner of the Black Diamond Award by Zeus Intelligence. In these two pictures, you can see in this one the liquefaction plant, and in this one the storage part of the same plant. These are the two tanks located. And finally, the last bunkering system, which is called ship-to-ship. This means that the consumer ship is fueled from a bunkering ship, which is loaded either from an onshore facility or directly from road trucks. So this implies two transfer operations. The first one is from the truck or from the onshore facility to the bunkering ship, and the second one is from the bunkering ship to the ship that it is actually fueled. Its main advantage is that large consumer ships can be fueled offshore from small ports due to the reduced volume of the bunkering ship. But there are still very few projects operating with this. So the different kinds of ship-to-ship systems, from the most complex to the most simple. The first one would take 5 steps. The LNG from the storage plant must be transferred to a road truck. The road truck transports it from the storage plant to an onshore bunkering facility. And there, from this bunkering facility, the bunkering ship is loaded. And then finally, the bunkering ship provides LNG to the consumer ship. The second one is where the loading bunkering ship is performed from road trucks directly. So the LNG comes from the storage plant to the docks by means of road trucks. There, directly from the road truck is transferred to the bunkering ship, and then the bunkering ship is who provides the LNG to the consumer. And the most simple, which only implies 3 steps, the LNG comes from a storage plant directly it goes directly to a bunkering ship, and there the bunkering ship is who provides the LNG to the consumer ship. And this is all. I really thank you for your attention, and if you have any question or you want to contact me, these are well, you have here my email. Thank you very much.